So I wanted to give you another example about the pressure at certain depths, along with how to use that pressure to calculate the force of objects that are under the water. In this case, we're talking about a viewing window of an aquarium, where if you might go underneath to bottom floor of the shed aquarium, you might find that there's windows that open up to the bottom part of the aquarium, so you can see fish swimming around. So that is this right there. So the dimension that I'm giving is a square window, and if we draw the dimensions right here, 20 inches by 20 inches. So the total area is 400 inches. So that's one thing we need to consider. But first of all, you need to find out the pressure, liquid pressure at 15 meters below the surface. So that can be calculated by taking the density of the water and times gravity times the height, which is again the height of the water level above the point we're interested in. Now, a couple of things here. The density, in this case, I didn't give it to you, but it's salt water. I did, and so the density of salt water is I'll give it as 1,030 kilograms per meter cubed. The height that we're interested in is 15 meters. That's shown here. And we know that gravity is the same, as it always is. So we take 1,030 as our density times 9.8 and the 15 meters. So we get 151,410, and because it's newtons over meters squared, we get pascals. Now, that's step one. Step two is find the force on the window. Well, if we look at that window, and we know the pressure, the liquid pressure at that middle of the window is what we just calculated. So there's a certain amount of force pushing in from the outside water. And so we can calculate that by taking force over the area. This is exactly the same thing we did with the cap that was on the end of the pipe at the bottom of the water tank. So we have 151,410 pascals force over area. Now the interesting thing is we have areas in inches, so we need to get that into meters squared. So we have 200 inches squared of window, and we can do this a number of ways. But 1 inch, put that on the bottom. We want to go from inches to centimeters. So for every 1 inch, there's 2.54 centimeters. And then we have to square that because we're dealing with area. Then we go from centimeters to meters, 100 centimeters for every 1 meter. Once again, we have to square that. So we get 200 times 2.54 squared divided by 100 squared. That's how I would have done it. So you get 0.129. Okay. And so that is meters squared. So you got 0.129 meters squared. So we take that and multiply it by the 151. And we get 19,536. So this is the force on the window.